Hi, we are from A4AS12049. Today, we're presenting about the analysis of food dyes in M&M using paper chromatography under CHM256 and prepare for Dr. Nur Shazwani. This is our team members, Nur Najwa, Nurin Marhanis, Nur Alia Hanis, and this is me, Siti Nurfatin Najwa. Introduction, theory, real-world application, methodology, result, calculation, discussion, conclusion,
My
and
name is Nur
reference.
Alihanis binti Muhammad Kafi. My ID student 2024933593. I would like to talk about the purpose of fruit dye as artificial fruit dyes. Synthetic color additive are using globally to make fruit visual appealing, maintain color uniformity, and assure brand recognitions. The regulatory bodies like the FDA and EFSA tightly control which drug can be used. Accurately identifying and separating test drug ensuring food safety and compliance. The M&M case study, popular candies like M&M use a blend of specific FD&C for drugs and cosmetic synthetic dye to create their signature shell colors. The aesthetic challenging, individual candy shell often look like a single color but are actually mixture of a primarily dry. We need to a reliable way to isolate them. Now, let's dip into the core theory behind how the separation actually works. Paper chromatography relies on two main components, stationary valve and the mobile valve. Our stationary valve is simply the chromatography paper itself. We made a tightly wound cellulose fiber. It stay complete stay. The mobile wave is our liquid solvent. As it sits at the bottom of the tank, it naturally climbs up the paper to calibration action, draining our sample along with it. So, how do the different fruit dry separate? It's all come down to the chemical ton of what is based on affinity, mean how strongly a dry is attracted to the paper or the liquids. Dry they are highly solvent in the solvent love the mobile wave. So they travel fast and move much farther up the paper. On the other side, uh, dry that interact more strongly with the cellulose fiber prefer the stational valve so they get held back and move a much stronger distance. There is a difference in movement is actually how allow us to see the individual color components clearly
My name is
separated.
Nurnaja binti Zahiri and my student ID is 2024947281. And right now I would like to talk about real world application. So the first one is food safety and analytical methods, divide by 3. And then the first one is comprehensive review on analytical trends, which is broad look at how labs detect restricted or illicit dyes globally. And then the second one is HPLC reference methodology. Read about the gold standard validations process that industrial lab use for separating complex blend of dyes. And then the last one is multi-dye quantifications for a study tracking the concurrent identifications of 11 synthetic dyes, including red, yellow, and blue under regulatory law guideline. Next, quality control and industrial applications. Divide to two, which is testing commercial foodstuff and industrial additive overviews. The first one talking about foundational study exploring high throughput method to extract and analyze dyes from commercial products like candies, drinks, and powders. It can be found in the determination of synthetic dyes in selected foodstuff by HPLC with your VDAD detection. And then the last one is paper chromatography and classroom guides. Also divide to two. First, classroom protocol guide, and then the last one is calculating RF values. Function of RF values is comparative look at utilizing paper chromatography alongside modern software tools to isolate RF values. So the next one, followed by methodology. So here are the procedure of an experiment M&M on a chromatography paper. First, cut chromatography paper into strips and draw a baseline with a pencil. Second one is extract dye from M&M candies using a drop of water and prepare food tolerance sample. Next, pour the dye solution onto the baseline and allow it to dry, followed by prepare 0.1% salt solution as the mobile phase, and then suspend the chromatography strips in the solvent with only the bottom edge touching the solutions. Moreover, allow the solvent to rise by capillary reactions until it is 0.5 cm from the top of the paper. Then number 7, remove the strips, mark the solvent plants and allow them to dry. Then the last one is measure the distance traveled by the solvent and dye spots. Then calculate the RF values and compare the candy dyes with the food coloring standard. So here's are the pictures that can guide you guys if you guys want to do the experiment. Next, I will pass this presentation to Nuri.
Now we will move on to the next slide. The slide shows the result obtained from the paper chromatography analysis of food dyes in M&Ms. Based on the chromatogram image shown, the dye separated into different color spots after the solvent traveled through the chromatography paper. This indicates that the M&M coating contains dye components that move at different rates. The distance travelled by the solvent was measured as 14 centimeters for all samples. For the red spot, the dye did not move from the origin and record a distance travel of 0 centimeters, giving an RF value of 0. This indicates that the red dye has a stronger attraction toward the stationary phase, which is the chromatography paper, and lower solubility in the solvent. For the yellow spot, the dye traveled 8 centimeters, resulting in an RF value of 0.57. This shows that the yellow dye had a moderate interaction with both the solvent and the paper. Lastly, the blue spot traveled the furthest distance, which was 11 centimeters, and produced the highest RF value of 0.79. This suggests that the blue dye had a stronger affinity toward the mobile phase and therefore moved more easily along the paper. Overall, the results showed that different food dye had a different migration behavior due to difference in their solubility and interaction with the stationary and mobile phase. Paper chromatography successfully separated the food dye and allow comparison using RF value. Now I will explain about the sample calculation that we use to determine the RF value. We use the formula RF equals to the distance travelled by the spot divided by the distance travelled by the solvent front. For the sample calculation, the blue spot was selected. From the result obtained, the blue dye travelled a distance of 11 centimeters, while the solvent front travelled 14 centimeters. So the calculation is RF equals to 11 divided by 14, which give an RF value of 0.79. This means the blue dye moved approximately 79% of the total distance travelled by the solvent. A higher RF value indicates that the dye has a stronger affinity toward the mobile phase, which is the solvent, and weaker interaction with the stationary phase, which is the chromatography paper. Therefore, the blue dye shows great mobility compared to the other dyes in this experiment.
Assalamualaikum and hi. My name is Siti Nofatina Job into my ideal Adha. My student ID 2024784033. Today, I will discuss about discussion for our topic analysis of food dyes in M&Ms using paper chromatography. So, the paper chromatography experiment successfully separates the food dye from M&M candies. Each dye travel different distance due to difference in solubility in the solvent and attraction to the chromatography paper. So the solvent front moved a total of 14 cm. The blue dye traveled the further 11 cm, followed by the yellow dye 8 cm, with the red dye remain the origin 0 cm. The RF value calculated were blue 0.79, yellow 0.57, and red is 0.00. So the results show that the blue dye has the highest solubility in the mobile phase, while the red dye has the strongest attraction to the stationary phase. The yellow dye show intermediate properties. Overall, paper chromatography effectively separates the dye based on the chemical properties accuracy of the result. Maybe you guys still wondering what is the conclusion about this analysis. So today I would like to talk about that. So conclusion, the paper chromatography experiment successfully separate the food dye from M&M candy and show that the different dye have different RF value due to the varying solubility and interaction with the stationary phase. The calculated of RF value were blue is 0.79, yellow is 0.57, and red is zero point 0, and indicating that the blue dye moved to the furthest while the red dye did not move at all. Overall, paper chromatography is an effective method for separating and identifying components in a mixture based on the chemical properties.